Good afternoon. I am Dr. Venkatesh. I am a consultant neonatologist. Today I am teaching physics behind the ultrasound. Physics is very essential component before you do anything using the ultrasound machine. We all know the sound is produced when the energy is passing through any media like air, water, solid. It produces vibrations. This vibration is nothing but sound. The audible sound, the human hearing is between 20 and 20,000 hertz, and anything beyond 20,000 hertz is called as ultrasound. In the ultrasound, by using three concepts are very important. The velocity, because the Doppler uses the velocity principle. Two other components, the frequency and the wavelength, of course the amplitude. If you look at the frequency, as you rightly see here, the frequency, if you see it, you get the number of waves. And we all know that the sound goes in a wavy manner. It has got two things. One is called the compression part. If I want to show you, this is the compression part where all the sound particles are aggregated, and here it is separated. This is called as rarefaction. And the frequency is nothing but number of waves per time. If you look at the wavelength, in between the two peaks, see this is the peak, this is the trough. Between the two peaks of the wave is called as wavelength. This is very essential for any person who does the ultrasound because this usage of the transducer. In neonates, because the chest wall is too thin and the whole body is thinner, fat content is very low, we need more resolution, not the penetration. To get the more resolution image, we need to use higher frequency probes. So that's the reason we use sometimes anything more than 4, 10, 12. So the higher frequency probes we use in neonates. In adults, because the fat content is high, we need to have more penetration, and more penetration means you need to use low frequency probes. So what is the relationship between frequency and wavelength? If you see the frequency is increased, means the wavelength is reduced. If frequency is reduced, means wavelength is increased. They are inversely proportional to each other. Clear about this? So after knowing this, I want to talk about what is called as the piezoelectric crystals, which are the backbone in any transducer. This is a transducer, and we have piezoelectric crystals. And piezoelectric crystals are made up of silicate or silicate crystals and nothing but zirconate, titanate crystals. And the importance of these crystals means when the ultrasound machine is connected to the electricity, the energy is passed from the electricity to the ultrasound. We get the electrical energy is passing through the ultrasound. When it is passing through the transducer, you will find there will be the vibrations in the piezoelectric crystals. Thereby, the electrical energy gets converted to mechanical energy. And this mechanical energy is going to different parts of the tissues like bone, skin, muscle, and then you got fluid, air, a lot of components. Depending on that reflectivity, so some of the waves they get reflected, some of the waves get absorbed, some of the get refracted. And when the energy which gets reflected back again distorts the piezoelectric crystals, mechanical energy is converted to electrical energy, and then you see the image on the cathode tube. This is how the piezoelectric crystals happen. If you see the conventional piezoelectric crystals, they are organized. If you look at, they are pure and not well organized. And what we see nowadays is called pure wave technology, where they are pure and they're very regular. And these piezoelectric crystals, if you see, they are precised. So they are more to get a good quality, good precise image. So most of the recent ultrasound machines, they use a technology called pure wave technology. So, in addition to that, as I was talking to you, reflectivity, different tissues have got different reflectivity. If if you take bone, bone has got high reflectivity, thereby you'll find a bone looks very hyperechogenic. The air has got least reflectivity, that's the reason actually it looks anechoic. Now, another important concept one should know is the Doppler ultrasound. If you look at the Doppler ultrasound uses a principle given by Doppler, a physicist, wherein whenever, suppose you are standing in a bus stop and an ambulance with a big siren coming to you, the pitch of frequency increases. As it goes away from you, the frequency starts coming down. So this is called as frequency shift. The same principle is used even when you do ultrasound Doppler using a flow, that is the blood vessel. So if you look into that, this is a beam, this is the blood vessel, and this is the velocity. Whenever there is an increased velocity, if you look at the beam flow angle is aligned. That means this alignment is almost towards the flow of blood. Whenever there is, the alignment is towards the flow, where the velocity is high, you get what is called as high frequency Doppler signal. But as the velocity recedes, you find, as you see here, so you see this, the angle, if you look at the C, it's almost 90 degrees, where if you look at the angle between the flow and the beam, it's increased. So that means more increment in the angle, then you'll find the velocity is also reduced, and what is happening to the signal, the high frequency Doppler signal, it starts receding at one point of time. When the beam is away from the flow of blood, it reverses also. This is in short Doppler principle that happens in the human body. There are three different types of Dopplers we use: continuous wave Doppler, pulse wave Doppler, and color Doppler. In the continuous wave Doppler, if you look at, sending and receiving crystals are continuously working, where you see the signal is sent to the tissues and immediately it is sent. So two piezoelectric crystals are used, thereby you'll find the process is continuous. This is used in the cardiology for getting high velocity profile, but the problem here is it cannot pick up the origin of the flow or origin of the velocity. If you look at the pulse wave Doppler, there is only one crystal is working, where the same person has to do sending and receiving information, thereby it takes some time, and this pulse wave Doppler is used for low velocity flow, and here we can actually definitely know the origin of the flow of blood. Color Doppler, you can see the color Doppler to know the velocity of flow and also which direction the blood is flowing, and usually when the blood moves towards the probe marker, it becomes red, and when it is away from the probe marker, it becomes blue. That is the reason a principle called as Watt principle. So in the nutshell, one should know what is sound, what is ultrasound, and what are the components of this transducer, how it works, and of course a short note on Doppler. Thank you so much.